Okay, all right, awesome. Thank you, Juan. Okay, cool. Thank you for coming in the afternoon. Thank you for some of you who've been here all day. Okay, so let's get started. Let's see. Oh, should I do this? Should I speak closer to this? Is that better?
We don't see the screen.
That is the screen.
No, I have to make him.
Oh, I see.
Hold on.
Oh, yeah.
Okay.
You got it? Okay.
Coordinating all these little details. Yep, thank you.
Give me 1 second.
Yep. Do I need to get out of Keynote presentation mode for that to work? Okay, share.
Now we see you.
Okay. Pardon me if I'm a little bit groggy-eyed or whatever. I got up this morning in Portland really early to catch a flight here. And then I had coffee and I had to sit in traffic for 2 hours. So that's not a good combination. So I'm going to start my first talk off with kind of some questions. So what if you could dramatically reduce network traffic? It's not navigating. Oh, there it goes. Hold on 1 second. Let's see. Okay. In one example, up to 97%. Less network traffic translates into less to do for the server. It also translates into less network traffic on your network overall. And then for the longest time, when you edit a record in FileMaker on a hosted solution, your edits are the complete record. The complete record goes up and down. So you make, let's say you have 50 fields on a record and you just change the date of some value on a record. It's not just the date that is transported up to the server and back down to clients who are looking at that record. It's the whole record. All the data, all the fields on that record go up and down. So, we're going to talk about some ways that you can send just the changed items. At least some piece of the network traffic is going to get reduced. We can also reduce the number of locks that the server needs to manage and keep track of by some of the techniques we're going to talk about today. And if you're using AWS, this could be a huge savings in actual dollars, because AWS measures the amount of data that is transported from AWS to and from AWS. What if you could improve the overall solution performance? In one example, we've improved the performance up to 93%. Improved performance translates into less data that users need to send to users. Performing data manipulations, transactions, doing things transactionally enables stored values. And stored values enable less network traffic, faster rendering, and possibility of also doing some auditing. So those are kind of like to get your mind thinking about what we're going to cover today. So my talk today is called Being an Optimist in a Pessimistic World. And it's talking about the way FileMaker works with record locking. Okay. I gave this talk in Europe at some of the conferences in Europe. And I also gave it, recently had the honor and the privilege to speak at the Japanese user conference. Was my first time in Tokyo. I took a lot of pictures of garbage trucks and cement trucks and subways, and they're all clean. I couldn't believe how clean those those trucks were. The city was very clean. I was very impressed. Impressed that they have really clean garbage trucks, nonetheless. All right, so my name is Vincenzo Bonanno. I'm at Beeswax. I'm the director of FileMaker development at Beeswax. I'm certified in all the versions 7 to 17, author of Inspector. This is my daughter, and that's my son, Luciano. Some of the things that we've done as a company, we do a lot of blog posts on various topics. And I want to just bring that up because there's some really valuable content there by different people on our team. Some of the things mentioned here, we'll talk about PSOS logging. There's a great blog post about master detail that Will did. Importing on servers, also a PSOS kind of technique. We did a number of blog posts about Tableau and how you can integrate Tableau and FileMaker together. If you do anything with web viewers, Simon's blog post about how to enable debugging with a web viewer so that you can run a command line and get the ability to get the full suite of debugging tools that you get in Safari right away in your in your window when you're looking at a web viewer. So if you do anything at all with JavaScript in a web viewer, that's a must to have. And I'll touch upon some of the other stuff with anyway the logging and PSOS later. But Apple Maps, if you integrate with Google Maps and you'd rather integrate with Apple Maps, one of our interns, Hiroshi, who came from the 42 internship program, it took him 1 day to integrate Apple Maps, MapKit.js, which is still in beta, but he got it integrated, and there's an example on the website. You have to be an Apple developer to be able to use it, but there's a great use case of that there. And then FM Ajax, Ryan, he's one of our senior developers. I think he's more of a web developer than a FileMaker developer, but he pioneered this FM Ajax thing that he's been doing for years, and that's definitely worth checking out. There's a number of blog posts from him on that topic. Our relationship with 42, we keep engaging to have students go through the internship program. And the reason I bring it up is because what's interesting about the internship with 42, and if you ever get to hire an intern through this program that FileMaker is sponsoring, and it's their 3rd round so far, that the students, you shouldn't look at the students as just pigeonhole them as FileMaker devs. So Hiroshi, the person I mentioned before, he came from that program, and he has a lot of JavaScript experience, more heavily on JavaScript than even FileMaker. So he lends a whole other perspective. Brandon, another intern, actually built his first FileMaker plugin recently, and that's not a trivial task. So you should look at their spectrum of possibilities broader than just FileMaker. So I invite you to kind of find out more about the 42 program and what FileMaker is doing with that. Yeah.
Just 42 or 42 something?
It's in Silicon Valley, the university is referred to as 42 SV. In Europe, it's just referred to as 42U, I think. So being an optimist in a pessimistic world, we'll look at security, we'll look at performance, the control that it gives you, but it comes with a warning. The warning is that if you're really going to step into this optimistic world, you really need to know what you're doing. And you might think it's the other way around. If you step into the pessimistic world, you need to know what you're doing. But no, FileMaker's inherent behavior is pessimistic. And if you're going to change it to work in an optimistic way, you need to know how to handle that and what you're doing to make it behave that way. So the way I talk about this and I go through this session is I kind of talk about the story of how this evolved for us and how we've made changes along the way to improve it and hone in on a more simplified way to do this. And so I'll talk about of the native editing behavior that we have in FileMaker. I'll then move on to something that we first started doing with global editing, and then something that we call local edits. And we'll talk about the data API and how that has impacted changed our vision of how to work with all this. And we'll talk about the benefits and drawbacks in each of those situations. One of the things that I like to do when I work on relying on PSOS is I like to get a sense of how much time it takes for a record to commit a change on the server. Now, a good way to kind of do a test like this would be, let's say you have a table with 100 fields and 50 of them are unstored calcs. If you want to take advantage of performance benefits, you might want to unhook those unstored calcs to become stored calcs. And one way to do that is to link all those unstored calcs to like a trigger field. And when you update that trigger field, you can cascade all those calculations to recalculate. And by doing that, just making that one change and committing the record, right, it will reevaluate all those unstored calcs, store them, and now you've got other benefits, which we'll see some examples later. And so I like to call this it's called a commit footprint. And so what we do is we test how much time it takes to commit a record in a table, and we get a sense as to how much work it is involved for that table to do the work to commit that. And we do an inner test and an outer test. The inner test is as close as possible to opening the record and making a change to some data and committing it. So that's what this purple area here is. So we're starting the timestamp, we're making a change to some data, we're committing it, and then we're ending that timestamp and measuring that distance here. Now, the outer measurement is a little bit more vague and loose, and it could be measured from the time you invoke it on your machine. When you call the script, you could test the outer constraints of the whole script. There's various ways that you can look at measuring the actual length of the whole thing. But the important thing is to get a sense of how much work it takes for FileMaker to open and close that record as quickly as possible. So we did some tests. When I was in Japan, I did some tests from a file that was here, and I tested how long it would take for a really small file just to open the record, commit some data, and then commit it. So that inner part took like almost 3/4 of a second to just from Japan with the latency and everything. I edited the record locally and then committed it. It took almost 3/4 of a second just to get that to happen. And then the entire outer loop took almost a whole second. That means I open a record. If I run it via script, the whole script took like almost a whole second. If instead I move that process to the server via PSOS, the numbers are very different. So the actual committing and making the changes to that record and that whole script to run, it is very, very small. So the closer you can get to the source of activity, the server, the better. So this is something that when we're kind of moving away from this, we want to know how heavy how heavy it is for that record in that table to do the work it needs to do to store all the values. So this is the kind of first thing we evaluate. So if you're doing PSOS, there's a lot of things to consider when you do work with PSOS. There are benefits for improving performance on a WAN. I'm not going to get into all the details about PSOS right now, but the main idea is that you want to take special care when relying on PSOS. We do have this PSOS log. It's a blog post on the website. You can go download it, and it's a cool technique to be able to give you insight into how long a script is taking to run on server, and then other things like how many scripts that are running concurrently at start and at end. So I invite you to take a look at that blog post. There's a lot of creative things you can do with PSOS too. Like you can build a way to send reports to be generated and queue them up. And so there's a lot of different approaches and techniques that you can come up with PSOS. But the main idea is that you want to be very careful not to overload too much on it. And you want to monitor how long it takes for every script to run and make sure that they complete correctly. Otherwise, they can keep running and running and running, and they're runaway scripts, and then they stack up, and then you'll get a disaster. So lots to consider with PSOS. So let's talk about native editing. So native editing, what I talked about that is just out of the box. When you open up a file, you click in a field, you start typing, and you hit enter. So native editing is what you get right out of with FileMaker. And you get pessimistic record locking. So you have 100 records in a table. It's hosted. It's a multi-user environment. I go land on a record, and I'll start in versions prior to version 7. If you clicked into a field, you would have locked the record. In 7, they introduced this twist to it that you had to start typing in the field to lock the record, and so you now, if you go into a record and you start making changes, you've locked it. FileMaker holds on to that lock, and if anybody else tries to lock the same record, if FileMaker knows that that record is locked by you, and it will tell the other user you can't edit it because it's in use. So FileMaker is managing those locks, and the more users you have, the more records are being locked for various things. FileMaker, I don't know the overhead that's involved, but it has to manage like the list of locks somewhere to keep track of it and notify the users. By default, there's no extra work. Out of the box, you've locked the record, you make the changes, you commit, your data gets in, no problem. No one else can get their data in, so you don't have to worry about collisions or anything like that. The drawbacks is that if you build out a complex solution with a lot of dependencies and different tables, you've got data normalized in different tables, and it's all related. Once you start building calculations to pull data from different relationships, those calculations are unstored. Building other calculations based on those calculations are unstored. Everything is an unstored spaghetti mess, or whatever you want to call it. And just like in Excel, where people complain and say, oh, this Excel file is taking forever to open, and it's long and slow. It's the same thing, right? So you've got sheets within other sheets, and this sheet is looking up data from these other cells and giving a result back to some other thing. So the more you keep building on top of that, the longer and slower things get, because they have to resolve to get the results to give other results upstream. Global edits. So this was our first approach to improving performance. And what this was is this idea of I'm sitting on a record, and I take the values off the record, I stick them into global fields in a popover. It could be a popover, it could be a card window, but the point is that I'm not editing the record. I'm editing the representation of the record in some global fields. And then when I'm done, I have a button and it says save. And I click save, and I take those global fields, I turn them into a JSON object, I send them to the server with the ID of the record. The script on the server locates the record, looks at the fields that I've sent, and checks each one and says, okay, yeah, this one's changed. Let me edit the change. Let me edit this other change. Okay, I'm done with all the fields you sent me. Let me commit the record. And that ability gave us this ability to break away from all those unstored calcs, because now if we go into that record, we can have it also evaluate and update those unstored calcs and turn them into auto-enter calcs. So now, instead of having all this unstored calcs that are being evaluated, we can have them become stored values. And we'll see some examples of the benefits that it can reduce in network traffic. So the global edits are cool because they can give you this introduction into optimistic record locking. So you don't lock the record locally. You're optimistic that you'll get a chance to lock the record at the time that you send the event. And as we saw, like, it doesn't take 3/4 of a second to lock the record. It takes 0.004 seconds to that sliver of time to put in your edit. And there's techniques to get it such that if you do have collisions, you can retry and keep trying until you get it in. There's other techniques as well that one could do. But so it gives you, it can introduce improved performance, because if you do things transactionally that way, then those unstored calcs become stored values. And we'll look at some examples where if you have even one field that's an unstored value on a layout, it has to go and pull the records down to evaluate that unstored calc. And pulling that down, not only there's time to do that, but there's also network traffic to pull all those related records down. So if you can break away from that as much as possible, then you can improve performance and you can reduce network traffic. So yeah. Mm-hmm.
Do those unstored calculations, do they?
Eric.
Oh,
Turn it on.
those unstored calculations, are they being evaluated even if they're not on the layout?
No, if the microphone is not on. And Eric is asking if the unstored fields are being evaluated even if they're not on the layout. No, they have to be on the layout. So let's say you have a list of projects and you have a % of the project completed with, like, let's say 10 tasks or 20 tasks. If you put that calculation to evaluate how many tasks are completed on that project, if that field is on the layout, if it's unstored to calculate that result across all the tasks, then it has to pull the tasks down, then calculate the result, and then render it, right? So if you have it in a form view, it's one thing, because it's just looking at that one record and you've got a related set of tasks, it's going to pull that down. But what if you've got that one field in a list view? Then for every single record there, it's got to pull down all the related records for every single one of them. And so it compounds the problem. So it can improve performance, ability to send only the changes, because again, let's say you've decided that only 5 of the 20 fields in that record are the ones that can be edited. Then you're only packaging up those 5 fields as a JSON object and sending them, not like with the FileMaker method, which is you're sending the whole record. Every time you commit that one change, even if it's a Boolean value, whatever, you're sending the whole record up, and then whoever has that record will get it then pulled down as well, because they need to get an updated version of the record. So,
In your example,
uh-huh.
I have
Oh, microphone.
So in your example, you talked about using JSON, and I haven't used JSON before. So the way I would have taken it is you make global fields, you paste the value in, and then you just set the fields afterwards. But you're saying that sends the whole record back, whereas JSON would just send that field back that you were editing?
No. So what I'm saying is I have a record. I click a button that is a popover.
Yeah,
In my popover, I have some global fields. I take the data from the fields that I want to edit. I put those values into those global fields. Okay, now I edit those fields in globals. There's no network traffic back and forward. And then when I'm done, I click save. And then whether you're using JSON or 6 fried rice or whatever parameter passing technique you want to do, you're sending those parameters in a script that gets sent to the server. So the record is still not being edited in any way. The script goes to the server, finds the record, and then puts in those values and transacts on the record, and then updates that record.
You could just use set fields, right?
Yeah, but if you can use set fields on the script that runs on the server. Absolutely. Yeah.
But your way is faster if you would do this through JSON?
No, JSON. There's no difference. JSON is just a transport mechanism to send the data that you've modified. That's all. The other benefits is, again, what I mentioned before, you can turn those into stored values rather than those becoming unstored values. And it opens the door for auditing. We do a lot of this where at the time that we're actually making the change to the record, we log what the value was before and after. We build an array, and then after we've made all the changes to the record, we send that array to an audit script that unpacks all that data and writes out all the changes that happened on that one record for those fields that were changed. So only the fields that get changed get audited. And we can say which ones we're interested in. So maybe the client only wants certain particular fields to be audited, etc. So those are all the benefits. The drawbacks with this approach is more work to set up. It's a little bit more effort to do this. And globals can crosstalk. This is the one problem. The main problem with this, or the downside with this approach, is I have a record in this window. I click up popover to edit the values on this record, but my client says I need to edit in another window another thing at the same time. So let's say you're the road manager for some rock band, and you're setting up the tour dates, and you've got all the tour dates, and you're booking the hotels, and you want to make sure that you're updating everything kind of like at the same time because you're booking the flights, etc. So you might have all those windows open for all those tour dates, and you might need to actually keep those things open to edit them. And so the global approach will crosstalk and mean that the last one will be the most active and then overwrite the values in the other windows. So that's a really big problem with this approach. And the other thing is you're relying on PSOS. You're sending it to the server. It's going to run on PSOS. So you have to manage that and make sure that things don't get messed up with that. Local edits is kind of where we're at right now. And these are systems that are in production that use this approach. And what this approach is, let me describe the approach before we actually get into the benefits and all that. So rather than globals, the local edit has a file that is embedded inside the hosted file in a container. It's a FileMaker file. And that FileMaker file has schema to represent some of the schema that you have in your hosted file. So let's say I have a concert tour and a set of, a tour. Let's say U2 is going on tour, and I have, dates for those concert events with tasks on each one of those dates. I can have the similar schema on that local file that's embedded inside, and then when the hosted file opens, it exports that local file to your temp directory, or to your, for us, if we're full access, it exports it to our desktop so we can quickly get to it and edit it, etc. But the main point is it exports it out and establishes a variable file reference to that file. Now, I can call scripts in that file, and I have layouts in that file that I can interface into card windows. So now the problem I had with globals is taken care of. I have a record here for U2 going on tour in Philadelphia on one record, and I say I want to edit this record. What it takes is it takes a JSON representation of the record and sends it to the local file, creates a record. Like FileMaker manages a local cache of data anyway. It's kind of our poor man's cache, if you wish, that allows us to then put that record in a state where you actually modify that record locally till you're happy with it. And then I edit another window, and I do the same thing, except now I get a new record in my local file for this edit in this window. So one edit here, another edit here, and they're all different. They don't crosstalk in any way. And so the benefits there are, you get rid of that problem where you're having the crosstalk. And it's the same process. You package up the changes, you send them via PSOS, and then you transact on the record to make those changes. So it's optimistic record locking. I'll get back to you in a second. It's all these benefits like you gain as a side benefit. Improved performance, ability to only send to changes, transactional capabilities, stored values, and auditing. The drawbacks are, it's, again, more work to set up. You have a local file to manage, but it's a little bit, it's like a little bit of a twist off of, you know, what is it? The UI separation thing, what they call data separation, where you have the data file and the UI file. Except for us, the UI file is part of the CRUD operations, and it's embedded inside the file. And it comes out only to reveal itself when you need it, when you want to do the UI CRUD operations. So it's kind of an interesting twist, and it's in production on a couple of systems, and it's doing really, really well. So you have to maintain a separate file. There may be some security concerns because you're putting data in a local file, but every time the edit is done, you could delete that data. So you have access to the record anyway. And so you're putting it in a temporary place, but you're removing it when you're done. So I don't know. And then it's relying on PSOS. Yes, you had a question?
So the local file only has a global variable.
The microphone, please. Thanks, Rosemary.
So the local file only has the local file.
It's a slow mic.
The local file only has the global variables.
No, the local file has records just like you would in a normal file. The global is a global variable that is established by the hosted file to get a file reference to the local file. I can show an example of that, so you'll see how it works. Any other questions about this? Clear? As clear as 2 p.m. on an afternoon in Santa Clara? But there's a new dawning in front of us. And that is the data API is transactional. We discovered that and we were blown away. And we sat there for a long time looking out far across the sea, wondering about the possibilities. It's a huge, big deal. This is really big, okay? Because, okay, and now we have this working in a prototype. But the idea is like, okay, let's look at what we were doing. Take this local file, we put it on the computer, we make edit changes, and then we send a JSON representation of all the fields that we've modified. Send it to the server. The server says, okay, let me find the record. Okay, this field, pick them out one at a time. This field, has it changed? Yes. Okay, build an array of audit changes, write that field to the record, this other field, this other field, this other field, on and on and on and on, okay? With the data API, this whole thing changes from a granularity processing point of view for looping over all the data points that you're sending, all the fields, to this like instead of like a streaming of little fields that you're editing, you're actually doing a big push in one push. So like you build a JSON object that supports the data API for a post or update, and then you're pushing that update with all the relationships that you need to update for that record, for all its integrity, for all its parents and children or whatever to update at that one moment. And so you're pushing that in, and it's one transaction, one step. And then you get back a success or a failure from the data API. And success means all the data was edited, all the data got committed, it's all good. Now, if any one of those related records were missing or were locked or failed validation, none of it goes in. So it's all or nothing. So you turn a script that maybe has 30 lines of steps in it to one line, one step. To just insert from URL with all that data packaged up. It's not trivial. You have to get all the pieces right for that to work over the data API. but we have done it, and it works. And then the other thing that you can do is when you push that event in, you're also building an array of all the changes of only the changed items that you're logging from that change. And you hold on to that, and if that was successful, you send the audited changes to the server via PSOS. Don't wait. And now that thing unpacks all that and logs all the changes. So it's turned into a very different, very compact, lightweight thing with a lot of complexity inside how it generates or prepares the JSON for that. Any questions about that? Jeff, I see you kind of pondering.
No, I love it too. You had some savings in cost for on AWS with PSOS, and using the data API, you're going to increase cost to, I guess, say, Foundry.
Well, are you getting, so sending? You're not getting costs on sending. You're getting taxed on getting. So we're only getting a reply back from the data API. Yeah. Okay. So I think we're good there. I mean, mind you, we're getting whatever JSON packet of, success 200 or whatever that is, right? So right. I think we're going to get, yeah.
Oh, you're right. Yeah, so you're getting very similar benefits as the PSOS, because the idea is that you're only sending the data that you want to change.
Yeah.
Yeah, so that's very cool. So,
okay, cool.
Does that mean that you're reconsidering some of your previous implementations?
Yeah, we're definitely, I mean, I think the bigger challenge is that the data API has one level of depth currently. So meaning that it's tied to a layout, and so we can only update a parent and a child record, and we can update anything that's connected as an offshoot to this record as related records off one step away. But you can't update a parent to a child to children of the children of the children, because you can't have a portal within a portal.
Right. So,
but if they break away from that and they use another construct, then instead of using the layout, you use the graph. Now you have the full, graph capability of what you can post using the data API. So there's a possibility there with that. Okay, so the data API, the benefits are, it gives you optimistic record locking, all the same benefits that we talked about before. You're sending only the changes, you get transactional capabilities, you can store the values, you can do all the auditing as well. And the drawbacks are, again, it's more work to set up, but less actually, because it's less coding. You don't have to set all those fields. You're just, preparing that one, JSON object that has to be exactly right for this to work. So it's might be a little bit more fragile than one might be comfortable working with. But if you know what you're doing and there's a process to do it, then it might be, it could be very reliable. And then you need the data API skills. So find a friendly data API JavaScript expert. And this relies on the data API. I talked about triggering calculations. So this is one technique you can do where you can attach your calculations that used to be unstored. Like, let's say my count of tasks completed. I can now turn that into an auto enter calc, and I can point it to become kind of dependent on a trigger from a modified field. So the modified field is just a timestamp. If I go to that record, and in our systems we have a field just called update, and when we update that timestamp, all the synchronization of all the unstored calcs fall into alignment. If I can edit the record and I can commit that value, then I get whatever's out there needing to be updated. And so there's just one trigger that you have to do instead of having to go to each calculation and update it with the calculation value that you had. you just turn it into an auto enter calc, and this is what the auto enter calculation looks like. So let's see. Let's do a demo. Okay. Let's see here. All right. Oh, actually, let's show a movie first. So what we're going to show is the second part of a movie, of a two-part movie, but we're going to show the second part. And so, Jeff, did you author this tool, or did?
I had an intern build most of it.
Oh, okay.
It was my dream child.
Okay. So, how many of you know about the network monitor tool? Have you heard about the network monitor tool? The network monitor tool, if you go to the community, FileMaker community, and do a search for network monitor, you will find a tool there, and that's this tool, this one down here in the bottom right. And it's very simple and easy to use, although it's a little bit, takes a little bit of setting up, like a laboratory test if you wish. But it allows you to monitor network traffic on port 5003. And so in this example that we're going to look at, we have a file that's hosted, and there's a field right here, this completed value. And that completed value in the first test was an unstored calc on the layout. And that unstored calc was just counting how many tasks for this concert are completed. Okay. In this case, in this example that we're going to look at, that field is a stored value now. So it doesn't need to have an unstored calc evaluated. It's already been evaluated and stored transactionally. So what we're going to do is run through it. And this is how you use the network monitor tool. Every time you want to run a test, what is it, quit and clear cache or something? And so before you run your test, you want to make sure that the cache is not going to affect any of the tests of how much traffic is coming down. And so you do that, and then you open up the network monitor tool again. And then, in this case, we're logging into the concert tours file. And then we're going to prepare ourselves to run the test. So we're going to go to a layout, and we're going to get into find mode. So let's a little bit of sound here. So we're going to get into find mode, and then we're going to start the test. And now we're going to perform our search on the record that we're looking for, and then we're going to stop the test. And then we're going to log. We're going to create a log entry for that test, and then we're going to compare the results. So,
You point out that you had to make no changes in the file.
yeah, Jeff said that, pointing out that with the network monitor tool, you have to make no changes in your file. You just have to make sure that you replicate the test scientifically, or like very accurately, like in the same conditions.
Right.
Yeah. So just to illustrate the point here that we talked about early on, so with the unstored calc, we're pulling down 6,101 bytes of data to evaluate. Just the only change that I did was take the unstored field to a stored state. And the first test was with the unstored field on the layout. The next test was with the stored value on the layout. And I ran the test, and the differences are, the stored value only pulled down 222 bytes of data. Okay, and that's probably all only with the representation of the record that I'm on, because it found the record and it pulled that record down. Outgoing was also a little bit different, and I don't know why in this case, why there's outgoing traffic, but anyway, it's still less. Okay, so a huge difference, and I like to refer to this example as a stupid, trivial little example as compared to real systems that are huge and complex and have really a lot of things going on in them. So this illustrates the point. And then I tried to amplify the point to some degree by also introducing that, like, the related records had some fields that were long verbose text fields. It could be the contract of each of the tasks or whatever. So just to kind of highlight the point a little bit more. So if you had fields in that table and there was a lot of data in them, all the data is coming down. So if you take this approach and the values are stored, you're not getting that hit locally. So it's a big deal in terms of in terms of saving the network traffic that's being sent down.
How do you then keep the store up to date?
How do you keep the score up to date?
The store.
So
So like in your example, there are 3 that were completed, but you know, they're over here completed the 4th one while we were talking.
yeah. So every time I send, like every time I make a task edit, I am not only editing the task, but I'm also updating the parent. So I update the parent sees that the tasks are completed. So I'll mark the task record as completed. I'll commit it. I'll go to the parent, all in the same script, and it goes and finds the parent and updates the parent. Again, remember the time for the FileMaker to open and commit a record is very, very small, well, especially if you run it on the server. So meaning that if I'm trying to, let's say we have a lot of tasks, and you're updating some, I'm updating some, and let's say we do them at the same time, and let's even say that we did them exactly the same time, such that you edited one task and I edited another. They're not going to collide because they're different records. But we manage to go back to the same record, and we say, hey, we have to update this record. But at the time that I update that record, you're doing the exact same thing in that 0.004 second time interval. It's locked. So what we do is we can just check again, like pause for a brief moment, check again, is the record available, try and commit it, And if we can't commit it, a couple of things to mention. One is we log an error and we get notified for that problem. The other thing is you got other problems. If you got things that are going on that are so transactionally heavy that you might be needing, to look at, maybe not thinking of updating it that way, or if they got lots of transactional activity, that might be not a solution for FileMaker to be so transactionally heavy like that. So a number of things to consider. But we did some stress testing on this exact thing to kind of feel more confident about it. We had about 18 people, and we all at the same time submitted our edits, and none of them collided. They all, kind of resolved in small intervals, maybe some collisions, but then they resolved right away. So there were no collisions whatsoever. So, any questions about this? No? Okay. Let's see, what else do I have? Okay. A couple of other things. So this is a case study on one of the solutions that we worked on, where about 5 years ago, the thing we were hearing often is, it's slow, it's slow, it's slow. And so we architected with the global field approach in this first version. And so we took a solution and we re-architected it. And so we had this opportunity to work a new system out of it. And we kind of got rid of a lot of cruft. We don't need these tables. We could get rid of these base tables. We can get rid of the tables. We can get rid of fields and scripts. But besides the point, the biggest thing that we focused on was getting rid of unstored calcs. So we made an intentional decision to move towards this stored mechanism of like updating the record only on the server, creating the data only on a server. The users never create records locally. They never delete records locally. They never edit records locally. So we had a huge reduction in code, okay, and improved and simplified abilities to, improved and faster transactional committing of data. And then the end result was opening this file from London used to take 33 seconds. It took now 5 seconds. Creating a new project used to take almost 20 seconds. It took 2 seconds. a project list would render in 10 seconds, renders in 2 seconds. And then an admin view used to take 15 seconds to display, only takes a second to display all like it's a huge dashboard of data on it.
They're all local fields and they're not indexed.
So unstored. So like in that dashboard, we had like 1, 2, 3, 4, 5, 6, 7 or 8 portals, and each one of the portals had unstored values of like things that it was looking at. And so each one of those was doing all the work to say, oh, let me go get all that data. Let me figure out what the total is and then displaying it. And all this was then just show the records from that table, just show the records from this table, because all you're doing is pulling only the data from each one of those tables down, and not the ancillary work of getting all the underlying data down as well to get the results of those values. So yes.
This sounds a lot like using a web client.
Yeah.
So I'm wondering if you had performed any objective testing. I just had a meeting with some prospective clients yesterday, and they were asking, well, what are the advantages of using WebDirect, because their management doesn't really like to use the FileMaker Pro client. Because this sounds like a way of not just improving it performance-wise, but perhaps either as an alternative to WebDirect, or maybe WebDirect is somewhat comparable in performance because you're not moving that data over the network.
Yeah, but if your values are unstored, they're still unstored, although they're being evaluated right at the server and maybe rendering the results maybe faster than you would if you.
That's what I'm thinking.
Yeah.
That WebDirect is already set to do everything on the server, if I understand correctly.
Yeah.
You're actually doing it in your web browser, so all the data is inherently at the server already.
Yeah. So 2 things. One, I don't have a lot of experience with WebDirect, and I hate it. I don't hate it. I just, I don't have enough experience to say it's my friend. So, and
It might be just interesting on
Yeah.
limited scale.
right.
To
Right.
compare the two, because I'm trying to recommend to the particular client what do you want to do. The first question always is,
Yeah.
what does your audience look like?
Right.
Because if they already have FileMaker Pro installed, why would you consider developing one WebDirect when you already have FileMaker
Right.
Pro as available to them?
Mhm.
But if they, performance where they have to reach across the network, and I do have a client that actually does have that issue, this might be a way, or either WebDirect or using this technique might be a way to deal with it.
Right. I mean, on a LAN, FileMaker is so efficient that having all this overhead and architecting this way, you might not, gain any significant advantages. Sorry. What's that?
WebDirect locally is faster than the app.
Well, so the thing about WebDirect is you still have a headless client on the server that's running to do all that stuff. So you're not pushing all the data over the network, you're still pushing the data from server into that, either onto your secondary machine or into that headless session. So if you're pulling up all that excess record data, your sessions are gonna have more overhead, so your server will need to be beefier depending on the number of clients you have. So using this approach of storing values and streamlining your architecture will also make all those WebDirect sessions more efficient. So you'll be able to have more sessions on the server because you're going to be holding less data in random for each session.
So using both techniques at the same time.
Both techniques meaning using WebDirect and this.
To
Yeah.
the local
So-
FileMaker client that's using this methodology to post things to perform on the server.
Right. In my testing with the over the WAN, and then I did the same test using PSOS to see if there was any difference. There is a little bit of a difference, but it's a little bit faster, but not much, or it's like a wash. So like if you were just building a system where you're in-house and everybody was in the same building and they had good networking, you might just not need to take all these steps. But so going back to this use case or story, once we architected this way, we have never heard a problem about performance since. It's been 5 years. So, and then different systems are now have implemented this way. And then the latest thing is like some of the newer systems have the local file approach where we're editing in the local file. And there's some really, really significant benefits with doing it with the local file. So we have one client where when they do some planning, it isn't just a record that they're editing. They're editing a whole array of values, and it's like a big cross-tab matrix of information that they need to edit and see totals real time and all this. All we do is we send a package of information for that period of time. We send it to the local file. The local file is just pure FileMaker, all the unstored calcs you want, all the summary fields you want. You just, all your skills with FileMaker apply. You just bring it up in a window, let them edit it. There's no network traffic ever because it's all local. When you're done, you package it up, you send it to the server, and it transacts it on the data on the server. And so you have a huge opportunity for, like, you know, very, very fast editing of data, because they could do it anywhere. They could do it in London, they could do it in Japan. It's all local until they're ready to send it. And then they just send it, and it transacts it. Yes?
I run into a similar problem with lots of records where it depends on the records with insert calculations that slow down the whole process. And I ended up making store calculations, and I'm running a script on the server to update them every second. Is that a test you've done as well?
Is that what?
A test? Did you look at a case like that where you just make the insert calculations, stored calculations, and then update them on your own?
Yeah, I mean, I think a number of people, what they do is they might want to update like a dashboard at some interval, or you'll see dashboards saying last updated on such and such a date. You know, maybe you want to do it at midnight and it represents something like that. And then it basically aggregates the data and stores it so that it, you know, you're just looking at data at that point. You're not having the extra overhead for it to calculate while you're looking at it. So yeah, there's definitely different ways to do that.
Yeah, I'm doing it like in a second.
It's
every second.
Every second.
And I see data's changed.
Oh, I see.
Which record was worked on. And so you'll calculate all the dependent.
Right, but what you're doing is you're doing it every second so that you can get a you know, a refresh of, you know, what's the state right now. But if you were, let's say, all the little individual pieces where you're putting in the data, what if at that point you refresh the parent every time? So those refreshes would happen only when the data was entered, and not like the server constantly saying refresh, refresh, refresh. So you know, different approach. Yeah. Any other questions? I can show you the file. We can take a look at it real quick. Let's see. Then I have just a few more slides, and then we'll take a break. So. This one. Okay, so we were looking at something like this. What you didn't notice is just when I opened it, I got this local file downloaded to my desktop, ZCT_local. That local file, this is a prototype version, so we're not clearing out the records, but normally we would clear out the records. So let me go ahead and show those records in here. So there's an add. So there's 30 records in here. Let me get rid of all those records. So I have no records in there. Let me look at my edit records. No edits in there. So let's look at edit. So if I go here and I say I want to edit this record, you notice how the record is created in the local file. Now this local file for the user, they don't know where it is, right? To them, it's like it's in their. They don't even know that it happened unless they have a really slow network connection and it says export field contents for a brief moment. And so, but that local file is on your drive. But the cool thing is what I was talking about before, which is if I need to edit the Elvis Costello tour in this window, Okay, oops. And I need to edit the Emerson, Lake, and Palmer tour in this window. I have my edits attached to the window, right? So I don't have to worry about crosstalk. I have a single record on both of those. I can manipulate them any way I want. Any changes I make here and I click outside the field, there's no data being transacted to the server. That's another big deal. Like some users, they might edit something, click outside, they think about it. That's like almost, that's network traffic. Depending on how big that record is, that's unnecessary network traffic or noise, right? So when I'm ready, all I do is I click send, save. It's just like the address book. It goes in and makes the change and audits the changes. Okay, and then this one, the same thing here. Can make this change date to, let's say June 8th. Then save it, and then that's June 8th. If I want to, and we have another approach where we're not just editing this part of the record, but we're editing the whole record and all its children. So we represent the same parent and children and the child in the local table. So we'll edit everything, parent and children. So we can go here and say, that's pushed out to March 8th. And we'll see over here March 8th. If we go look at the audit trail, we'll see that 2/7/18 to 3/8, like it was audited. That value was audited. So I'll zoom in a little bit for you. So the completed task for that task was changed from February 7th to March 8th. Okay. So again, doing this with FileMaker, you have the whole record moving. With this technique, we're sending it over the data API. And the thing that we're kind of evolving to or experimenting with is in the current implementation of the reliance on PSOS to do the transaction on your behalf. So we have a separation, right? We have the script that runs locally to capture the data, generate the JSON for it, and then send it to the server, perform a script on server with the data I'm sending you, and that runs full access. So if I go back to my slides briefly here, skip over to here. So typical security would look something like this, where you have ability to edit for, like let's say one privilege has the ability to edit, might have the ability to view in a lot of tables, deleting only in some tables, right? So you have like certain granularity of privileges. The current implementation is they only have view access. So they can never create a record, no matter what. They can never delete a record. They can never edit a record. Now, had this discussion last night with Matt. He had a few drinks. He was kind of pushing me. He says, I don't like that, like you're opening up a hole because you're running a script with full access. Someone, if they know that script, they can, like do stuff. And so yeah, he had a point. And maybe with the data API, we don't need to do that because with the data API, it respects your permissions, whatever they are, and then we're just sending that transaction to happen with the same privilege level. So it would respect that. The only thing I personally don't like about it is that I prefer that they can't do anything, and then you'd have to make sure they don't have enter access into any of the fields. They can't lock a record accidentally. You have to lock down the menus. I kind of like this idea that they can only view data, and the stuff happens transactionally on the server. Chris was kind of on my side last night, Chris Irvine, but
Who's the modified by? Full access.
What's that?
Who becomes the modified by?
I mean, you capture the credentials of the user that's running the script, and you send that as well. So, but on the record, we don't have in every single table a created by, modified by field, because we only have like a trigger timestamp field. All the auditing happens in the audit table. So we're logging, and we need to know who did it and who changed it. So we kind of save 4 fields. We don't need to put them in every table because we have a robust auditing mechanism, and we can tell who created the record and when it was changed.
Could you review how they get the local file?
Yeah. So let me show you how you get the local file. Okay. So when I open this solution, right? Let's see here. It goes and determines if I'm full access, and I get the file and I get the path, and I calculate whether or not we're going to save it out to the desktop or the temporary directory. So I define a global variable, okay, path $$ path, and it will have the path either to the desktop or to the temp directory. So for users, we put it in a temp directory. For us, because we want to make maybe changes to it, want to get access to it quickly, we put it on the desktop. And then all you do is you basically, you would export the file here, full access exports the file. And here it exports it to the desktop. And then that this path variable is contained within the external data sources over here, right? So that's a variable file reference. And that's established at the time that it opens. And the only time that you can redefine that is you can redefine it, but the file has to be closed to redefine it, to define a different path to somewhere else. So so that's how it puts it there. But then once it's there and it's on the desktop, you can do things like you can call scripts in it, right? So perform script in that local file, and you can call any script you want in that local file. And the really cool thing is, let's see here. The really cool thing is that I have to save it first to delete it. Oops. Okay. Oh, no. Really? You didn't see that. That was weird. Okay. Yep. I'll send it to Jeff. Where did it go? This one.
You delete this local file?
Yeah, I mean, this prototype thing, we're not deleting it on close, but normally on close, you would clobber the file, so there's no trace of it. On submitting the data, you would then remove the data that you have. So there should be, like, if you're not editing or creating data, there should be 0 records in any of the tables in the local file.
That's what it used to describe the file.
You say export field contents, and then you say nothing for the what was it, the field name, or how do you do it again? You say you get the path of
It's empty.
the what?
Your container field should be empty. So there's
The container. Oh yeah, the reference of what you're exporting should be empty, and then you give it the same path, and it clobbers the file. Yeah, that's kind of cool.
Is the file still there and empty?
No, the file's gone. It's clobbered. It's destroyed, obliterated, vanished.
Replace something with nothing.
yeah. So you don't have to use a plugin.
So you don't have to use a plugin. What else to say about this? Yeah, so the data API has a lot of interesting twists to it that we can probably take advantage of, and we're exploring more and more of that, and we want to move towards that, so that there's maybe a little more lightweightness to it. Although we're not sure yet, because
when you're pushing the JSON back, is it coming from the local file?
the JSON is, so everything is going through the hosted file. The local file never talks to the server.
Okay.
So like,
it never does.
no, so the local file, like you only work with the local file to put the data in there, edit it. When you're done, it talks back to this file. This file sends it to the server. Yeah. Yes.
Is there a security issue with it being a foundry file in the temp directory? And is it just accessible, or do you need credentials to it?
No, I mean, that file is kind of, so two things. If you host a file with an auto-enter password on server in default location, you can't. It will not open the file because it has an auto-enter password. However, because this file is embedded, like we wanted to call this the Trojan horse technique, but we decided that would be a bad name. But because the file is embedded and it's local, when you open it, it uses an auto-enter account name and password that doesn't give you access into the file. So, so from your point of view, you can't get in there. Even if you went to the temp directory and you looked at the file, you would have nothing to work in there or do anything in there. So, let's see. I have maybe a few more slides, and then we should take a short break. I think. Oh yeah. So let me skip over that. Let me talk about this. So, how many of you use allow creation of related records through a portal? You use that? So let's say. What's that? Yeah. You have a portal, and you say, I'm going to let users type in there and create their related records, etc.
Oh, in the portal. In
the portal. You don't use that? Okay. A lot of people use it. Yeah, and so let's say you were entering, nutritional, let's say us as a group had the task of entering nutritional information for fruits and vegetables or whatever, and you had to enter vitamin content, I had to enter nutritional content, and all this, and we look at the broccoli record, and you go there and you start typing your vitamin content, and I go to the same record, and oh dang, it's busy. He's got it locked. I got to wait till you're done. So and every time you enter some information, it takes you about 15 seconds to look it up, enter it, commit it. I get lucky in the interim while you're looking up the next one. I get in. Now you're locked out, right? So there's a 15-second interval. Let's pretend, to enter one piece of data. So let's say that was the same for any one of these. Our work through the day had a lot of information to gather. You could enter in a minute maybe 4 items or something, really, really limited. But if you do it transactionally, where you put the data in a global and you submit it, that little very fine-grained moment just goes in, puts it in, relates the data, and then it can even update the parent as how much nutritional items that this record has, etc. So in the same span of time, you can enter about 5,000 pieces of data compared to the, like the very limited amount of data. So just kind of like a fun way to do the math and think about this. Okay, recap, optimistic record locking, considerations if you do choose to do optimistic record locking. There's a lot of things to consider. It's not a trivial little thing. And so there's a lot of things to make sure that you get right. You can control calculations to happen when you want them to happen rather than them being unstored. The thing I hate the most is once you're unstored, everything is unstored. Because you need this other calc for something else. It's unstored. It's going to force those other downstream calculations to also be unstored. And you have considerations using PSOS or the data API. So just take a 5-minute break, and then we'll have maybe 25 minutes to talk about Inspector. I just need to get some water. So is that all right? 5 minutes? Cool. Thank you. Oh, awesome. And then, was there any questions online? Eric, did you see? No.
You're on coffee, I think.
I'm coffee sitting in traffic.
Peter's starting to freeze here.
All right. So I'm not going to spend too much time on this, but tell you what's coming, what we have in the lab. Unfortunately, I'm going to strangle Brendan later. Anyway. What's that? No, something went wrong with my highlighted feature that I wanted to show you, which is a real drag. But anyway. So I'm going to talk about what's coming in the next release and what we're focusing on and what changes we've made. So, areas of improvement, We're going to cover these in more detail, but it's a comprehensive tool. Inspector does more than just parse the DDR and tell you, like, you know, you have these fields and these scripts and these layouts, etc. It does a lot more work, and we're trying to bring that kind of forward in a more kind of direct way, so that you can see and choose if you want all this extra work. Some of the things that it's been doing in the past has been doing all this extra work, and some of these other tools don't do that extra work. And so it's kind of like, huh. So what we did is we opted to have you choose whether you or not you want it to normalize and cross-reference all these different aspects of the DDR. If you're only interested in where things are referenced and what problems you have, you would be twice as fast. So we've broken it down into different components. We've added more effort around search. We improved comparison. We added some collaboration features, and we'll talk about those, and performance and data visualization. So let's look at comprehensive. So with Inspector, what we do is we have a whole slew of other bits and pieces about the DDR that we extract and put into very easy navigatable and viewable information. I'll give you examples here. So let's say I want to. So this is all of the areas that we do. So we give you information about all these different aspects, like import mapping, different import types, what kind of auto-enter lookups are there, etc. Let me give you 3 examples to show you in like a scattering of these. Let's look at, let's see, where is it? This one here. Oh, where did it go? Oh, here it is. Oh. How do I get? This is all written in FileMaker, yes. Where did I put it? Okay, I'll just bring up another window. So a good one is layout destination. So layout destination, if you're looking at layouts and you want to get a sense as to if you use any indirection for layout, go to layout name by calculation or something. When you ask Inspector to do some processing, you have the ability to choose whether or not you want to generate all this extra information. Okay, so if you generate all this extra information, then what you get is this, ability to drill into any one of these areas. And the UI is not finished on this, and they're color-coded for a particular reason. But let's look at layout destination. I can click here and see, oh wow, I mean, I have 197 places where I reference go to layout name by calculation. And so, that might alert me to the fact that the solution is using indirection to navigate to specific layouts. So I have to be aware of that. So if you were deleting layouts, you'd look here and see like, oh, I'm not using indirection, and those layouts are not referenced. You have a higher confidence to be able to delete the layout. And we have other things that we're adding to even give you more confidence in that area. So this layout destination is one of them. Let's look at script steps. Same thing with script steps. We list out all the steps that are available and what version it came available, what version it was modified in, etc. And then you could click on any one of these, and you would get a listing of all the places where that step is used. Okay, so like if I was looking for show me all the perform script on server references, I could see that here. Okay, so I could go there and I could click on it, and it would drill into the script where that's referenced. Now, you could equally as well go into the script step table and go do a search for that, but that's very inefficient because you're searching on not the ID, but you're searching on the string, and then any further imports then would be very slow. The whole thing would get slower. So this is actually a very optimized way to find those references. If you don't need it, again, you can just uncheck it, and you don't need to bother looking at those if you're focusing just on references and dependencies, but very useful. And then one last one we'll look at is state. So there's different states in different steps. So like a perfect example is wait for completion. Okay, wait for completion has got a true or false state on the perform script on server. So we have a way to filter by different types of states, right? So I can say, I want to find all my pause true or false states in any one of these script steps, okay? Or I want to look at wait for completion, and wait for completion, I have true or false. And so these are the ones that wait for completion. These are the ones that don't wait for completion. So it gives you all this insight, and you can get at it both from the state option, or you can get at it by looking it up. You know, I want to go look up perform script on server this way. So you can go look at the script steps that have states, or you can look at the states and see what script steps have those states. Just this alone is just been a massive amount of work because it's everywhere, and it's a lot of detail to cover. So we go back to the slides. That's a comprehensive bullet point about all these 100 other aspects that we normalize. And now you have the option to run it or not run it. And it takes a little bit of time, but if you choose not to run it, you're actually saving that time, and it runs faster. Because the other thing that we did is, I'll talk about in the performance. We broke it down into groups. The other thing we added is this concept of table distance. And so we worked with, we put this into the plugin such that we give it a list of fields and tables and relationships and fields that are in those relationships. And it does all this processing in C to generate a comprehensive mapping of like, hey, I have a field on this layout that's 5 hops away because it's referenced in this table occurrence that crosses all these tables. And there's a lot of, this is just the beginning. We have a lot of rich information about all the hops and what, if it crosses any relationships where there are globals, where there are predicates that are greater than or less than. There's a whole bunch of information that we can get at in terms of that jump. Okay, and so that'll be useful to look at fields that are on layouts and see which ones of those are coming from faraway distances. But it'll also be useful in looking at calculations that are evaluated from a particular context. All the field calculations, the auto-enter calculations, the validation calculations, the security calculations, anything that has an anchor for a context, you'll be able to use this in conjunction and get some metrics on like, hey, that calculation is very slow. Well, it's slow because it's doing all this extra work. Script steps don't have a context because it's at runtime. So we don't know where you're actually evaluating that calculation from. So, yeah. Searching, we're adding the ability to search across an entire analysis. Each analysis is going to be in an individual floating tearaway window. So I can look at this analysis and open it in a different window. I can open this other analysis in a different window, and I can search like a global search across the entire analysis. So I could do one search for like, find me everywhere I have the word ID or name or whatever. We're also, we've had for the longest time, we've had searching in all calculations. So that's something that is combined with the search across all areas. So those two things are going to be combined. And then we're adding we're building in logicator support. So there's going to be a UI where once you're in fields or scripts, I can go and say, hey, I want to search for the field name equals this, or so there's a very consistent UI. Because one of the things is that there's just such an amount of information in some of these tables where like, where do I enter what to search on? Where's the auto enter calc field that I can enter to search on that? So that's going to be a big help. Comparisons, we made some improvements there where we finally support different named databases. So I build a file, it's called contacts, and then I clone that file, and I call it contacts, or monster, whatever, okay? But they came from the same file. But when you import them, you can import them into the same analysis, and you can compare them, even though they're different files. So we didn't have that before because we were building the hash, and it was including the name of the database in the hash. Now we don't do that, so it's interesting how that came to be. Collaboration, we did a lot in collaboration. For the longest time, we had the ability to host Inspector on the server, and we have various installations for people doing different projects, and they host Inspector and they upload DDRs to the server. It's really cool because once it's hosted, you generate a DDR, you say, I want to upload it to the server. As soon as it's transferred the DDR files to the server, you can close your laptop and go home. So I sometimes upload 1, 2, 3, 4 DDRs, and they get queued up, and they'll process one, and then they'll work on the other one. They don't work on them simultaneously. And so uploading them to the server is very quick, and some of them take 5, 10 minutes or whatever to process. And so I don't have to wait for that time. I just upload them and go. We've had this, and we improved it. We have notes that you can attach to any object. When you attach a note, the note carries forward from analysis to analysis. So I uploaded an analysis. I have a field on a layout. I add a note to that object, and I say, don't remove this field off this layout, whatever. Or this script is, a critical script. Make sure you don't, touch it or mess with it. If I bring in another analysis, it sees the note attached to that object. It carries the notes forward. So I don't have to re-enter the note if I upload another analysis. Multi-user accounts because it's hosted, so different people can get into it, and you can work as a team. This is another big deal, and this is manual references. So let's say I have a script that's used as a script schedule. The script itself will not show any references to it being referenced by anything. So you might think, oh, I could delete that script. But you can go into here and mark that script as a manual reference to being run by a script schedule, and then those also carry forward. So like once you've entered it, it's always going to remember it as a manual reference for future updates. We have integration with HipChat and Slack. HipChat got bought by Slack, but we still use HipChat internally. So anyway, but when it ships, it's only going to support Slack or HipChat for us. But anyway, and so when you generate a DDR, where is it? Let's see. You have the ability to say solution, post into the channel, that Slack channel, that the solution was created, the solution was deleted, analysis has begun, analysis was completed processing, or an analysis was deleted. Plus, you'll be able to do other types of actions, like maybe post a number of problems or things like that. But it can post things into the room using the API. So that's kind of cool. Oops. Let's go to the next slide. So performance. We've been doing this for a long time. We do the processing on the server, so we call it PDoS rather than PSOS, process TDR on server. The big thing with this next release is we split them up into groups. So in the past, what we would do is we would have 440 XSL files. For every XML, it would have to parse 440 XSL files. We re-architected the plugin to understand things in chunks and groups. So now when you parse a DDR, what's going to happen is it's going to upload the DDR. It's going to parse the core items like fields, value lists, tables, and it's going to get that done first. Once it's done, you can go in and start searching and doing stuff. So it's going to be more responsive in terms of being able to get in there sooner. And in the background, it's still working on calculations, calculation dependencies, and then extra stuff if you needed it. So it's going to feel much more responsive because you're going to be able to get in there and start looking up stuff right away. It has been multi-threaded for a long time. and it still continues to be so. And then we're bringing back some data visualizations, and we're bringing back the force-directed graph, etc. And I can show some of that. Unfortunately, Brendan broke it. So I'm going to have to describe to you what it's supposed to do. Let me see. Let me try one more time and see if maybe I did something to break it. Yeah, so he broke it. It's too bad. What it was supposed to do is it's generate a visualization like this, okay? And what it would allow us to do is we've had this new feature called a script viewer, and the script viewer would allow us to do things like this. Let me show you. So I would log into a solution like this one what we had before, and this one is integrated with the script viewer, such that when I get in here, as any script that runs here would light up the corresponding node on the script visualizer in real time.
What's running?
Yeah. So if Brendan was in Japan right now and he would run a script, the nodes of all the scripts that he would trigger, it's too bad I can't show this to you, but you have to imagine it. So if I were to go to here, I would get one node that would light up, okay? And then if I were to save it, then what would happen is, because it's a chain of scripts that would run, you'd see all those other scripts light up as nodes that were triggered. Now, what's interesting about this is that if you have a solution where you see a certain pattern of activity, you can say, these are the critical scripts that I need to kind of watch out for. And you can see how busy the system is. You can see there's activity going on. And we were even thinking of attaching little sounds that you could kind of turn off or on. So it could even be in the background. It could be dinging away, like, you know, and if it gets really quiet, then you start wondering, okay, maybe something's wrong. But anyway, this is some of the enhancements that we've added.
Do you keep statistics too, which scripts is running most of the time?
What's that?
Do you keep statistics, which script is running most of the time?
Yeah, I mean, this is going to be this is also going to have a script log of all the times that the script ran. Although we're not sure, you know, if we're going to be able to log how long that script ran exactly, etc., because it's a little bit more involved, and not everybody will use like a single pass loop approach. So it, you know, might not work for everybody. But by default, all you would have to do is insert one script step at the beginning of your script, and then that script step would do a call. We tried it with the data API, but it's a little bit slow. So we might, for now, be using the XML API until we feel that the data API is faster. And the XML API is much better. But it's really cool when, you know, Brendan is in Japan and he's running scripts and you're seeing the nodes light up of what he's doing. And, you know, we could explore doing other things as well, maybe color coding who the users are and seeing who's the user that's running that script or whatever. But we're logging it all, so I don't know. We have the information, so we can see if we can add some other features. But
So you can put that on some monitor in the company?
yeah, the other thing is this is embedded within Inspector. But the final approach is that I would be able to say, oh, I've generated, like, so I went to my list of scripts, okay? And so let's say I go to my list of scripts and I say I want this script, and this script. These are the critical scripts. And then I would say generate a script monitor for those scripts. And it would be a file that's got all the logic self-contained in it. And you take it and you host it wherever you want. And then in your system, you point the code to say, oh, it's hosted over here. And then it just updates that one. And that's your monitor. And so it's very lightweight. It's decoupled from Inspector. It's a way to generate it so that it has all the code to generate it. And then you just transport it to anywhere you like. And then And then if you have the sound options on or off or whatever, it could be cool. Yeah, so I've got 8 minutes left. Can use that time to have discussions, whatever you like. We can chat about, let's see, we can chat about log files. I just had this funny picture. I have to see if I can show it to you somehow. But I was in Portland yesterday, and at the Ramada Inn, I don't know how I'm going to send it here. Let's see. The Ramada Inn, at the entrance of the Ramada Inn, there was a box, and the box had this funny picture on it. I'll have to show it to you. It's funny from a database perspective. Oh, that's not it. That's Marriott. So we'll just wait a moment to get it. Anyway, I'll take some questions. Anybody have some questions? No questions? I'll wrap up. Oh yeah, go ahead.
Earlier you were saying that as you put the global variables, you collect them as a JSON and send them up to the server, from straight on the server. You had a way to queue them. Then you just queue them in a table and execute the table to avoid collapse of two JSONs being the same record being updated at the same time.
Okay, so to avoid the like collisions on the same record, so what we use is see, I don't have one in this example, and I can't show you the file that it's in. So what we use is a technique where we know what the parent is. So all of our primary keys are made up of the table name and a UUID. And so when we get a key, and we send a key to that script, we say it's called transaction update. We send that key. It says, oh, the table is this. Let me go to that layout where we have a corresponding layout for each of the tables, and I'm going to use this key to search for that ID in that table. And I know that there's an update field at every single one of those tables. And I can set a field, set field by name to be find that record, and set that field by name to be the timestamp and update it. Now, if someone else submitted a record and also needed to update that same parent record at the same time in that 0.004 second interval, right, and we both collided on the fact that the record is locked, then that script would wait momentarily and try again. And then it would wait again and try again. And we give it, three attempts or 5 attempts. And then if it fails, we log an error and we send an email. And so that's a technique where you avoid those collisions. But if you're getting those collisions in the first place, it's maybe the commit is taking a long time. Maybe you have too much transactional activity. There's a lot of factors to look into.
Yeah, I'm wondering if you are just doing the table as a job schedule, and then run the job schedule.
Yeah, you could do that too. Like if instead you prefer that those updates, because let's say you, for whatever reason, you have a lot of record, like a lot of people needing to update that one record very, very frequently. So instead of having it always look at that record and update it, you could just have a scheduled script that would just kind of come around every minute, every 2 minutes, find that record. And that's the only task that script does. And if that's the only point of edit for that record, like no one else edits that record, then that script would have full control to go in to find that record and update it. No problem. No collisions. You're welcome. This was at the this is at the lobby of the Ramada Inn. For a moment, I thought there were real logs in there. Anyway, if there's no other questions, one question online? Online? Oh, you have a question. All right.
Can I say example? Can I say an example?
Just got to give it some time. It's an old microphone.
Okay. Can I see an example of the searching, like searching all over the place for like, a piece of text or something like that?
I don't have the interface on it, so trust me, it's working. I just don't have the interface all finished on it. So, but it works. Okay. So, what's that? Early next year. Early next year. Yeah. I have to find Brendan first. Cool. Well, I guess last year I presented at the end of the year. This year I did the same. So thank you very much for coming. In the middle of the afternoon. Good luck with traffic. I don't know if we like the middle afternoon thing, but thank you very much. See you. Have no choice. You're going to move out east again. What do you care?
Well, I mean, it has to be during the day.
Yeah, no, I know. I'm just a little bit coffee punchy, whatever. But
Do 1 to 3 instead.
yeah, no, it's fine. That's fine.
Who's gonna host this?
I'm working on that.
Yeah. This is the end of the year, so thank you very much to all the people who participated online, and we'll see you in the new year. Eric and we've been already getting a long list of people for the new year, so we have lots of exciting speakers coming in for the new year. So stay tuned. Thank you, everyone. Goodbye.